I think it's worth our time to do one more like this. This one we do not have an initial concentration of 0, so it is a little bit more challenging to determine in which direction it will shift. But we do just as we did before. We will solve for the Q value and compare it to the K value. We have initial concentrations. We're asked to solve for equilibrium concentrations. We'll start with the ice table, write the chemical equation and the initial concentrations that we've been given, and then solve for Q. We'll take the hydrogen iodide concentration, initial, square it, and the other two concentrations in the denominator. We get a Q value of 0.5. Q is still less than K, so this reaction will shift to the right. So we're going to have minus X for the reactants, and because there's a coefficient of 2 on the product, plus 2X. These then become our equilibrium constant expressions. Our equilibrium concentration expressions. Then we will solve for X by plugging everything into the equilibrium constant expression. And this one appears to be a little bit more challenging. As we quickly see, we can't take the square root. We're going to have to FOIL out this term, and hopefully you remember how to take two numbers being added together, the whole sum being squared. We'll get 4x squared plus 0.4x plus 0.01. Then we need to do the same thing here. We will get 0.02, and we will get negative 0.1x plus the negative 0.2x, so the negative 0.3x, and then the last term, x squared. We still have to come up with one expression set equal to 0 in order to use the quadratic formula, so we're going to have to multiply both sides of the equation by this denominator. When we do that, we will be left with just this on the right-hand side, and we'll have 57 minus this on the left-hand side. So that's what I've done. 57 minus this whole thing right here becomes 57x squared minus 13.1 x plus 1.14, and then that is set equal to what was over here in the numerator. I then collect all my terms, put everything on the left-hand side, set it equal to 0. I get 53x squared minus 17.5. Let's see, this was 17.1, not 13. Minus 17.5x plus 1.13. I can then use my quadratic formula, as I did before. I will get two values, 0.242 molar and 0.088 molar. If X were 0.242 molar, this value right here, this concentration, would be negative. Actually, this one would also be negative, so I cannot use this X value. This X value is the only plausible X value. I can then solve for all of my concentrations at equilibrium by plugging X into all of these expressions right here. These will then be my equilibrium concentrations. To verify that they are true concentrations, I will then plug them back into the equilibrium constant expression to make certain I get 57. As I mentioned in the previous lecture, these types of calculations can get rather difficult rather quickly, as you noticed with that last problem, although we were able to solve it just using the quadratic formula. And all of the calculations that you will be performing in this class you will be able to solve with the quadratic formula.